So I'm the co-founder of UMA. We build financial infrastructure for Ethereum. What that means is two sets of financial infrastructure, actually. One set is smart contract templates that you can use to create decentralized financial products really easily. And the second is a decentralized oracle that you can use to validate final payouts of these financial contracts. And so a lot to talk about today. We're going to be talking about how to secure DeFi products to trillions of dollars of value. And the two sets of financial infrastructure that we at UMA are building really actually inform this question. So maybe starting off with something that most of you in this room probably won't find too controversial, financial innovation can be really useful, right? Products and services like borrowing, lending, stocks, bonds, things like that, they really add value to people's lives, and they help to grow and build the economy. The problem is that really great financial products, in theory, they really don't matter if the payouts from these financial products can get manipulated. So probably one of the recent scandals that many of you may be familiar with that has really gotten a lot of publicity recently is around the LIBOR scandal, where there was this really great financial innovation around interest rate swaps that allowed people to create and trade risk in long-term financial products, long-term debt. But the reference index that was used to value these interest rate swaps got manipulated. Well, here's the scary part when it comes to DeFi. We believe that any on-chain oracle can be corrupted. So any DeFi product, any smart contract that relies on an external price reference, an oracle, we actually believe can be manipulated. So how can you possibly scale DeFi protocols to trillions of dollars? Well, maybe first, actually just one more silly example here around, to hit home why this question matters. If you and I do a trade, right? Let's say we're trying to bet on whether it's actually going to rain today here at the London DeFi Summit. You would think that what we care about is whether or not it actually rains today. But because smart contracts are dumb, if we just have self-enforcing, self-executing code, right, we don't actually end up caring about whether or not it rained today. We end up caring whether the oracle will say it rained today. And so this is why economic guarantees matter for on-chain oracles. Let's maybe backtrack for a moment and talk about why things actually work at all and why things have scaled into trillions of dollars in the fiat world. In the fiat world, there's all kinds of rules against fraud, right? The governments will basically enforce an external cost upon any would-be attacker or any would-be manipulator. When you and I enter into a contract in the regular world, hopefully we're entering into that contract believing that we will each abide by the terms of that contract. We don't enter into the contract hoping that we go to court. But because we both know that we can go to court, and that if you did something to manipulate markets in your favor for purposes of this contract, that you'll go to jail, we both end up behaving honestly, even if we may not necessarily be actually the most honest or scrupulous people in the real world. Blockchain contracts have no such concept, right? So with blockchain contracts, there is no international government organization that is necessarily going to track down and trace down every single possible case of fraud here. There is no external consequence for any would-be manipulator of an on-chain oracle. And by the way, it doesn't even have to be malicious. It could just be some sort of a hardware malfunction. A server goes down somewhere. But at the end of the day, if your on-chain smart contract, if your DeFi product is relying on an external price feed, there's just no consequence if a problem happens with that price feed. So let's give actually another concrete example. One of the most high-value use cases within DeFi so far has been within lending protocols. So the use case would be, I own a bunch of ETH. I'd like to borrow money against my ETH rather than sell it so that I can actually spend that money or so that I can lever up my ETH. This all sounds great, right, in theory. But the reality is there's supposed to be all these rules governing how much collateral I'm required to post, and there's rules around when my collateral will get seized and liquidated. If the price of ETH goes up, right, I would expect that I should be all good. But all of this information comes from an oracle. So in all of these DeFi lending protocols that are popular right now, even the ones that have scaled to hundreds of millions of dollars, they're ultimately still requiring or dependent upon the accuracy of an external price feed. And there hasn't really been a mechanism so far that actually resolves these price feeds in a truly decentralized way. At some point or the other, if you dig deep enough in the code base of these protocols, many of them ultimately still come down to a centralized or semi-centralized solution as a safeguard or protection against the possibility that these oracles go wrong. So this is just now when DeFi is a few $100 million, of value. At scale, this really becomes an even bigger problem, and especially a bigger problem if you layer on pseudonymity, where imagine Bob is a malicious attacker here, right? He can actually enter into contracts across multiple protocols, or with multiple counterparties in massive size, and effectively create for himself a massive honeypot, where if he was able to somehow bribe some external reference price, there's some configuration of the world where he could earn a massive amount of profit. And he will do this at some level of scale for some price. This will happen. And this is why oracles need an economic guarantee. Especially in a permissionless blockchain, these economic incentives are the only tool really that you can use to incentivize the right behavior. And so we believe that DeFi cannot scale into trillions of dollars of value without oracles that have economic guarantees. Of course, economic guarantees can be quite expensive. And so we actually don't believe that it's kind of a question of what kind of oracle do you need for the job. We don't actually believe that you need the expensive decentralized oracle for every single moment in time. Actually, you really only need these oracles if there is a dispute or at final settlement. Going back to the original example that I gave earlier about two counterparties entering into a contract with one another, hoping that or believing that both will abide by those terms and only going to court if there is a dispute, the same thing effectively, or the same concepts analogize into DeFi, where if you have a smart contract, you don't really need this expensive settlement oracle for every single point in time. You really only need it if there's a disagreement or if there's a lot of value at stake on a final payout. And we're going to, later on in the conversation, go into all of the mechanics around how we at UMA have actually built this and what we're testing. But first, an exciting announcement. We talked earlier about how UMA is building two sets of financial infrastructure, and they both kind of bootstrap each other, right? All the stuff that I've talked about with decentralized oracles so far, it only matters if somebody's using a decentralized oracle, right? If you have great products that need an oracle. And great products only matter if they use a trustworthy oracle, one that cannot be manipulated for profit. So now we're going to jump back and talk about basically a new product innovation enabler, I would say, that UMA has built. So we've just launched, you guys are actually getting the inside scoop, our synthetic token builder. Basically what this lets you do, literally any of you in the room, it lets you really easily customize, deploy, and experiment with synthetic tokens on testnet. Synthetic tokens are basically our first smart contract template. The way they work is you deposit some amount of collateral, and then this synthetic token builder lets you create customized ERC20, so standard tokens, whose value tracks some external price reference index. The cool thing about these synthetic tokens is they really only require an on-chain price oracle if there is a dispute or at final settlement. And in the meantime, these synthetic oracle tokens are simply just traded in the marketplace and track the value of something else. I'm going to just play a quick little video that shows you just how fast it is to create a synthetic token. So this is the actual interface. You're interacting with a smart contract, and you're basically determining the parameters of this smart contract that you want to deploy. In this case, I think we're creating a synthetic gold contract that expires at the end of the year. 2 clicks to interact with the blockchain, and then a decision here around how many synthetic gold tokens you actually want to create and how much collateral you want to collateralize it with. And boom, it's actually done. This happened faster than I could talk. We've created a synthetic gold token. It is actually, you would be able to see it on Etherscan on the Rinkeby testnet. And any of you in this room could basically create custom exposures for pretty much anything that has a price index using this little tool. And so this is what I think is powerful about DeFi. Better, faster, and more composable than all of the alternatives. A lot of the stuff that we're doing in this blockchain space, the problems become a lot easier if the world was already crypto native, but the world isn't crypto native, the world is fiat native. So what are the products or innovations that we can build to actually catalyze this transition? I'm going to go over a few examples. This particular image here is just, for those of you who were watching the news yesterday, NASDAQ just announced a DFIX index. They created an index whose value tracks the token value of some DeFi projects, MakerDAO, 0x, Augur, etc. It's not tradable, it's just an index. Well, using the synthetic token builder tool, you could actually go and create a tradable token today that tracks this particular index. So it really speeds up the development cycle for financial innovation. Here's a few other examples of different things that you could do or create using the synthetic token builder. But the whole point of all of this is to try to lower the marginal cost of innovation. It actually ties back really nicely to Lex's keynote about reducing the marginal cost of financial innovation to 0 and letting users rapidly experiment and iterate on financial product ideas. The 7 kind of logos on the right here are real projects that were created by hackathoners actually last weekend. We did kind of like a little private beta test with some hackers there, and they came up with some really cool ideas around ways to use synthetic tokens and UMA synthetic token builder in their projects, ranging from interest rate products that help us enable price discovery on DeFi interest rates to a cross-border crypto payments system that would, instead of using ETH or DAI, actually use local currency, to a Bitcoin dominance index. So making something pretty abstract, like how dominant is Bitcoin in all of crypto, into a tradable, investable product. And then there's also this one. Many of you may have heard of Dan Robinson from Paradigm. He wrote a white paper, I think a week or 2 ago, about the yield protocol, which is basically trying, it's a specific product implementation that's trying to build out a yield curve for ETH dollar funding rates. From one week from his white paper to testnet, we can actually use our technology to create these Y tokens. And so we did it. We created Y tokens. We deployed a Rinkeby instantiation of Uniswap, which is an automated market maker and liquidity pool. And we made these Y tokens tradable against DAI in Uniswap. And I mean, I said it was 1 week from the white paper to testnet, but really it was 1 day. My co-founder did it last night for this presentation. Okay, so that is that's kind of the announcement that we're making today around ways that we're trying to lower the barriers to financial innovation. But again, ultimately, all of these great financial product ideas in theory, they only matter if they can actually be sustainable and scalable, and if we can connect them to an oracle that has economic guarantees. So how can we do this? The core concept is actually really quite simple. The general idea is that for any on-chain oracle, there is some value that you could pay to corrupt this oracle. We'll call that the cost of corruption, COC. For any on-chain financial contract that requires an oracle, there's some profit that you could make if you could corrupt that oracle. So we'll call that the profit from corruption. And so pretty simplistically, if you want an economic guarantee, just make the cost of corruption higher than the profit. So what we've designed is a mechanism that actually ensures this. And linking it back to those silly stick figures from earlier, right? The cost of corruption is the bribe that Bob would have to pay to this external reference, and the profit from corruption in a crypto context would be the amount of margin inside of these smart contracts. So the steps here are really actually quite simple. We need a mechanism to actually observe the cost of corruption. We need a mechanism to observe the potential profit from corruption, and we need a mechanism to keep costs of corruption greater than profit and actually prove to everybody that it'll actually work. So the way that we actually do all of this, we define the cost of corruption as being the observable market cap of tradable voting rights, where owners of voting rights would participate in a Schelling point style game to validate the final payouts or prices or price requests that are coming in from our oracle. The profit from corruption is done via a contract registration where financial contracts that want to use this oracle have to abide by a certain interface and certain terms. And we simply look at how much margin is held inside of these smart contracts. And then our mechanism to ensure that the cost of corruption is always greater than the profit from corruption is basically a variable fee policy, a dynamic fee that gets assessed periodically to the users of the oracle out of the margin that's in these contracts, and then used to buy and burn voting rights until the market cap of these voting rights once again gets to a level that is safe and maintains this economic guarantee if it was to ever fall close to or below that level. I think I'm going to skip over the math slides, but the general idea here in terms of measuring our model of measuring the profit from corruption, it's actually very, the cost of corrupting an oracle is very similar in concept to kind of a POW-based attack, where you would basically have to own or bribe half of all token holders, effectively override the honest majority in order to take over this oracle. And then the profit from corruption is actually quite straightforward. As long as you're able to measure the total value across of margin locked across all contracts, then you can get the potential profit from corruption. And all we need to do basically is maintain a minimum value in these tradable voting rights that is greater than the potential profit from corruption of the contracts that are using this oracle in order to guarantee that the system, or in order to ensure that the system has an economic guarantee and the cost of corrupting it would be greater than the potential gain. For all intents and purposes, a simple way of looking at it would be looking at the market cap of the voting tokens relative to the total margin in the system. And as long as the first is greater than the latter, then we're safe. But you might want to put in a little bit of buffer as well. So let's just call the target market cap kind of your safe market cap or your safe price. The way that we actually enforce that the system is safe at all times is the oracle charges a dynamic fee to the users of the oracle if it is deemed that the system is ever unsafe. And then we use the proceeds of that fee to buy voting rights in the open market and credibly burn them until the market cap reaches a safe level again. So a way of looking at the system is to basically say that the market cap of the system is equivalent to the sum of all expected future cash flows, the sum of all expected future buybacks, effectively. And the cost of using the system in perpetuity is that same thing, a discounted sum of all future fees taken out of the oracle users to pay for the oracle voting right holders. So we can actually basically mathematically model out what the market cap of a token would be relative to the market's expectation of what future usage of these financial products would actually be. Oh, and because of this, actually, one of the really cool outcomes of our modeling is that during early days, during the growth stage, using the system can actually be completely costless. Because during the valuation of these voting rights is based on the discounted expectation of all future cash flows, right? So if you believe that DeFi will one day scale into the trillions, then the market cap today of these voting rights should be far higher than where we're starting at from today from a financial contract usage perspective. So you can actually guarantee that you have a very, very safe Oracle system with very high economic guarantees today because we have low usage today but high expectations for future usage. So basically, where we are right now is both of these sets of financial infrastructure have already been built. We have our first smart contract template, the synthetic tokenization template, already out. Any of you could interact with it on the Rinkeby testnet using the interface of our synthetic token builder. And some of our partners are actually have either already deployed or are in the process of deploying mainnet use cases as well. Just to kind of give you some of those examples, earlier this year, one of our partners used this technology to basically create an ERC20 token that tracks a major US stock index. And so the idea there was anybody who has access to crypto can also now access on the same global infrastructure US stocks. Some of the other projects that some of our partners are working on include kind of similar products in terms of like off-chain assets, but trying to deliver them to people living in countries that are capital flow constrained or don't have access to the financial infrastructure that would normally give them access to these products. And then one of the other kind of mainnet projects that we're working with some of our partners on right now is around synthetic stablecoins. You don't necessarily want to create and replicate an entire MakerDAO system for every single currency under the sun. But depending on what country you live in, generally people are still thinking about their expenses and denominating all of their activity in their local currency. So we're actually working with a partner who's building a digital payment system in a developing country to deploy a synthetic stablecoin for his payment system so that his users can get rid of the cognitive load that comes with doing the mental calculation of how much ETH or how many dollars per local currency unit, and instead just directly create these local currency tokens for them to use inside of this payment system. So that's all live. Our decentralized Oracle system that I mentioned earlier that this whole presentation was about, that's also deployed to testnet. We're just doing some internal testing at the moment around how to set up voting nodes, making sure that all of this infrastructure is usable and scalable. And then our internal priority is really getting this product to mainnet before the end of the year. And then in parallel, we're also working on additional contract templates that can securely interface with this Oracle, and that, again, really expand the range of financial products that we can offer, or expand the range of financial products that builders can actually create using our infrastructure. So basically the last thing that I'll leave you with is an action item calling any builders that are interested in building new cool financial products on Ethereum. We'd love to work with you. As I mentioned, we've already worked with several projects, both on mainnet and on testnet, to use our templates in our Oracle to make the financial products that they want to give to their users a little bit easier. But if any of you have ideas, we'd love to talk to you. Regina, my colleague, is also doing a workshop right after this. I don't know which room, but she's doing a workshop right after this that really dives into the financial engineering behind our synthetic token builder, and talks about design considerations that you should make when you're inventing new financial products. So that's it for the presentation. I think we have a few minutes for Q&A if anybody has questions.
Thanks for the presentation. It was really good. So one question I had kind of goes back to that comment on if you expect DeFi to grow to trillions of dollars, the discounted cash flows, it would be more safe than necessary, but wouldn't that also mean that it would be more expensive?
That's right.
Okay, that was just the question.
No, I think that at scale, like let's assume that DeFi does get to trillions of dollars. Effectively, what would happen at that steady state is that users of these financial contracts would expect to get taxed on the amount of margin that they put inside of these financial contracts. And the amount that they would be taxed would basically be equivalent to the opportunity cost of a Oracle voting right holder for the amount of capital that they're holding. Like, would they prefer to own these voting rights that are worth just let's say $100, or would they prefer to have $100? And owning the voting rights would basically come with the ability to collect taxes. So if you assume that like at steady state that you want, I don't know, a 10% annualized return, then that would roughly translate into a 10% annualized tax on users of the system. But the cool thing about the way that our smart contract template designs work is that we actually allow under-collateralized leverage. So what that means is if you have a position that's 10x levered, it means the amount of margin in your system is actually only 10% of the total notional risk that you're transacting in. And then if you tax that by 10%, you only end up having to pay a 1% annualized fee to use this very secure system.
Thank you.
It sounds like you guys are essentially competitive to Chainlink. Are you thinking of creating a more, I guess, generalized solution, not only for UMA contracts, so other dApps can have this kind of voting token model?
So I think that's a question of what Oracle is right for the job. So I think where Chainlink really excels is in fast DeFi. Like if you need a price and you need it on the next block, or however long Chainlink's latency is, that's great. What Chainlink also does well is around kind of redundancy, or maybe almost like on-chain DevOps, where if you're trying to get, let's say, the price of ETH dollar from the Coinbase API, rather than just having a single node reporting on it, Chainlink could have all of the Chainlink nodes reporting on it for redundancy reasons. And that has value. But it's not particularly decentralized. So where our Oracle, I would say, offers a differentiated value from Chainlink, but with some trade-offs, is the ability for the actual outcome, like what is the price of ETH dollar, the ability for that outcome to be resolved in a decentralized manner and for human judgment to be applied to that outcome. But unfortunately, our system, I would expect to be slower. We'll obviously work on optimizing speed, but it's not necessarily something that you can use if you're trying to get a price in the next second. I think it's possible, although unclear, what cost differences will look like between the two systems at scale. There are possible ways for the two systems to actually even be complementary. Great. Thank you all for being here and taking the time. I hope you learned something about DeFi and the dangers of oracles today. If you have any questions, please feel free to talk to me after the this session or attend Regina's workshop.